Somewhere north of Siberia, a line of cargo ships sits frozen in place. Engines running, hulls locked into ice more than 2 meters thick. They aren't broken, they aren't lost, they're just stuck, waiting. Because out here, past a certain latitude, the ocean isn't water anymore. It's a solid white sheet that runs all the way to the horizon, and a normal ship that pushes into it doesn't get through. It gets trapped, and then it gets crushed. Then, in the distance, something moves. A single ship comes up behind that convoy, and it doesn't slow down. It drives straight into the ice at full speed, and the ice just loses. A crack races out ahead of the bow. The frozen sheet splits open, and behind the ship, a clean channel of black water opens up like someone pulled a zipper across the Arctic. One by one, the stranded cargo ships fall in line and follow it out. Now here's the part almost nobody realizes. That ship leading them to safety has been at sea for months. It has crossed this frozen ocean over and over again. And in all that time, it has not stopped for fuel one single time. Not once. Because it doesn't need to. It can run for years on a single load. And that fact, a ship that simply doesn't refuel the way every other ship on Earth does, isn't science fiction. It's a design decision engineers made more than 60 years ago. There are 3 layers to this story. The first explains why a machine like this has to exist at all. The second reveals the technology keeping it alive out there. And the third is something almost nobody expects. By the end of this video, you'll never look at a ship the same way again. So let's start with the obvious question. How does a ship stay out for years without refueling? Most people assume the answer is simple. It just carries enormous fuel tanks. Bigger ship, bigger tanks, more range. But that's not it. And once you understand why, the whole thing starts to make sense. A large icebreaker doesn't sip fuel. It devours it. Smashing through ice several meters thick is one of the most power-hungry jobs any vehicle on the planet ever does. A diesel-powered ship trying to do the same work would burn through its fuel in a matter of weeks. And here's the problem that changes everything. Out in the middle of the Arctic Ocean, there are no fuel stations. There's no port. There's no tanker waiting around the next bend. There is nothing but ice for 1,000 miles in every direction. So a diesel icebreaker has a hard limit built into it. It can only go as far as its tank allows, and then it has to turn back. That's fine for a short job near the coast. It's useless for keeping an entire shipping route open all year long. And that route is the entire point. It's called the Northern Sea Route. It runs along the top of Russia, and it's becoming one of the most important trade corridors on the planet, because a ship traveling from Asia to Europe across the Arctic can cut thousands of miles off the trip, compared to going the long way around. Last year alone, tens of millions of tons of cargo moved along it. But there's a catch. For much of the year, that route is frozen solid, and the only thing that keeps it open, the only thing standing between global trade and a wall of ice, is a fleet of icebreakers that can stay out there indefinitely. Which brings us to the second problem: the ice itself. Here's something most people never think about. Ice at these latitudes isn't a thin crust you can chip through. In the dead of the Arctic winter, sea ice routinely reaches 2 to 3 meters thick, and in pressure ridges where 2 sheets have slammed together, it can be far thicker than that. To force a path through it, a ship doesn't cut the ice, it climbs onto it. The bow is shaped so the ship rides up on top of the frozen sheet, and then the entire weight of the vessel, tens of thousands of tons, presses down and shatters it from above. Doing that once takes an enormous amount of power. Doing it continuously, hour after hour, day after day, for months, takes a power source that essentially never runs out. And in the 1950s, engineers realized there was only one kind of engine that could deliver that. Inside the hull of one of these ships, sealed behind meters of shielding, sits a device most people will never see and most people have never heard of. It's about 7 meters tall, roughly 3 meters across, and it weighs many hundreds of tons. It has no exhaust pipe. It burns no fuel in the way you'd normally imagine. On the newest Russian icebreakers, this device is called the RITM-200, and it is a nuclear reactor purpose built for a ship. And here is the number that stops people cold. The energy locked inside nuclear fuel is so concentrated that a single fuel pellet, small enough to hold between two fingers, contains roughly the same energy as a full ton of coal. That's the whole secret. That's why the ship doesn't refuel for years. It isn't carrying a bigger tank. It's carrying a fundamentally different kind of fuel, one so dense that a small core can power a ship the size of a skyscraper laid on its side. The newest of these vessels belong to what is called Project 2220. They're the largest and most powerful icebreakers ever built. Each one is about 173 meters long, wider than a 10-lane highway, and carries two of these RITM-200 reactors side by side. Together, they push the ship through ice up to 3 meters thick and drive it at 22 knots across open water. And the refueling interval, the time between one fuel load and the next, is roughly 7 years. Let that sink in. Your car needs gas every week. A jet needs refueling after a single long flight. This ship runs for the better part of a decade before anyone thinks about touching the core. And it's about to be outdone. Russia is building an even bigger class next, powered by a larger reactor called the RITM-400, with more than double the thermal output. Those ships are being designed to smash through ice more than 4 meters thick, ice that today's icebreakers would have to go around. When they arrive, they'll be the most powerful icebreakers the world has ever seen. But here's the question nobody ever asks. What happens when something goes wrong out there? Picture it. You're 1,000 miles from the nearest port. Every direction is ice. It's the polar night, which means the sun won't rise for weeks. The temperature outside is deep below freezing, and the wind makes it feel colder. And you're sitting on top of 2 nuclear reactors with no Coast Guard coming, no tow truck, no help within days of you. This is why these ships aren't just powerful, they're obsessive about redundancy. There are 2 reactors, not one, so if a problem forces the crew to shut one down, the ship can still limp forward on the other. The reactor design is built around what engineers call passive safety, meaning that if the systems lose power entirely, physics itself is supposed to bring the reaction under control without anyone touching a button. And the crew running it isn't a handful of sailors. It's dozens of specialists, many of them nuclear engineers, who train for years before they're ever trusted with a core in the middle of the ocean. Because out here, the ice doesn't negotiate, and the nearest rescue is measured in days, not hours. Every safety margin has to be built into the ship before it ever leaves port. Now here's what surprises everyone. You'd assume a machine like this, a nuclear-powered ice-crushing giant, is a grim, industrial place to live. It isn't. Crews are at sea for months at a time, so these ships are built more like floating towns. Sailors get private cabins that look less like a warship and more like a modest hotel room, with a desk, a bunk, a small fridge, a private shower. There are lounges, saunas, a pool, a gym. Because when you're going to be locked inside a steel hull in the polar dark for half a year, comfort isn't a luxury, it's survival of a different kind. And there's one more thing almost nobody expects. Some of these ships don't just escort cargo. In the summer, one of Russia's nuclear icebreakers takes paying tourists on a voyage straight to the geographic North Pole, the very top of the planet, a place you literally cannot reach any other way. The same reactors that shatter Arctic ice for freighters also carry travelers to a spot on the map where every direction is south. But maybe the strangest part is this. These ships could keep going long after the people inside them have to stop. The reactor doesn't get tired, it doesn't get homesick, it doesn't need to see the sun. It could run for years. In the end, the thing that limits one of the most powerful machines ever built isn't fuel or ice or engineering. It's US. So the next time you picture a ship, don't picture the fuel dock. Picture a vessel out past the edge of the map, in the dark, on top of an ocean turned to stone, carving a path that nothing else on Earth could carve, running on a piece of fuel you could hold in your hand. Now, I want to hear from you. Would you take that trip to the North Pole on a nuclear icebreaker if you had the chance? Or does the idea of being iced in for weeks sound like a nightmare? Drop it in the comments. I read every single one. And if you learned something today, hit that like button, subscribe for more, and I'll see you on the next one.